Welcome back to the Math Professors. Here's a problem that you'll find in Calc 3 when we're looking at three-dimensional geometry. So what I want to do is compute the equation of a plane through two lines, and I've given these two lines parametrically L1 and L2, and you can see how they're defined. Now we know the equation of a plane is given by this, a times x minus x naught plus b times y minus y naught plus c times z minus z naught is equal to 0, where the vector ABC is the normal, so it's the perpendicular through the vector, and it passes through some point on that vector, which is going to be x naught comma y naught comma z naught. So I've kind of drawn this graphically. What I'm trying to do is I'm trying to find this this green plane given the pink line and the blue line, and I know that two lines are going to define a plane. And again, what we need is we're going to need a point, and we're also going to need a normal. So this is the two things we can find. Once we know those, I can just plug it into the equation. So first, let's go after the point. Now, I know that these two lines are going to intersect at that particular point. So at least I know that that is going to be on that plane, and we're just going to use that particular point. Now, in order to find that, I need to find, the point is going to happen at, the intersection of the lines. So the way we're going to intersect these lines, I'm just going to set the x coordinates equal to each other, the y coordinates equal to each other, the z coordinates equal to each other. So the x is going to be minus 1 plus t, better be equal to 1 minus 4s. Now the y's also have to be equal to each other, so 2 plus t has to equal 1 plus 2s. And then similarly for the z's, each z has to be the same as well. Now, these two equations will be enough to resolve a value for s and t. And they'll give us the same coordinates for, x and also for y, given those s and t's. But remember that two lines in 3 space could have the same, x and y coordinate, looking at down above on my two arms, but they could miss in the z's. So what I need to also do is plug in s and t here to make sure that they actually, intersect at not just the x and the y's, but also at the z's. Okay, so I'm going to solve this. I'm going to isolate, isolate this one for t. So t is going to equal, adding 1 to two sides is 2 minus 4s, and then I'm going to substitute it like we would in any algebra class for that t. So 2 plus, t, which is 2 minus 4s, has to equal 1 plus 2s. Now this is only an equation of s. So simplifying, I have 4 minus 4s is equal to 1 plus 2s. And let's add 4 over here, and then we'll subtract 1 over here. So I'm going to have 6s is equal to 3. So s is going to be equal to a half. So now what I'm going to do is I'm going to plug that back into here. So then t is going to be equal to 2 minus 4 times 1 half. So then 2 minus 2 is going to be equal to t, which means t is going to be equal to 0. And let's kind of check that this works. So if t is equal to 0, I'm going to get negative 1. And then if s is equal to a half for here, I'm going to have 1 minus 4 times a half, so it's going to be 1 minus 2, which is going to also be negative 1. Let's check here. When t is equal to 0, this will be equal to 2. When s is equal to a half, this will also be equal to 2. So this is working. Now we do have to check here. So plugging in t is equal to 0, 1 minus 0 is going to be equal to 2 minus 2 times a half. I also have to check this equation. So this is going to just be 1, and this is going to be 2 minus 1, which is 1. So boom, they actually do intersect. So then our point, and we get to choose again, because remember they give you the same x, y, and z if I plug in t equals 0 here, or if I plug in s equals a half here. So I'm going to go after the t equals 0 because it's much quicker. So plugging in t equals 0, we're going to get the point, x is equal to minus 1 plus 0, which is equal to negative 1. Y is equal to, plugging in here, 2 plus 0, which is equal to 2, and then z is going to be equal to, plugging in here, 1 minus 0, which is equal to 1. So I'm going to say my p naught, because it's going to be the intersection point, is going to be minus 1, 2, 1. All right, now we're almost there, because we've found our point. Now what we have to do is we have to find a normal. Now the normal to these to this plane needs to, basically look like this. I'm just going to kind of draw it straight up. What I need is a normal, which is going to be, perpendicular to plane, which actually means it has to be, perpendicular to both of those lines. And the way we can generate a perpendicular to two lines is I can take the cross product of their directions. And what I know for like the pink line, if I want to know its direction, which is going to be, this thing right here, its direction is simply going to be the coefficients in front of t. So, that vector is going to be, 1, 1, -1. So that's going to be the vector 1, 1, -1. And then very similar for my blue one, my blue curve, this is going to have direction, -4, 2, -2. So I'll squish it in there, but that's going to be -4, 2, 2. That's going to be that direction right there. So if I want to find its normal, what I can do is I can cross those two directions. So let's say it this way. I'm gonna write it formally. It's going to be the cross product of 1, 1, -1 with the vector -4, 2, and 2. And we know the way we build a cross product is going to be I, J, K, or one way. And this is 1, 1, -1. This is -4, 2, and 2. -4, 2, and -2. -2. Boom. And make sure 1, 1, -1. We're happy with those. Okay, so now when we generate this, this is going to be I times, when I do I, that's going to be those four. So 1 times -2 is -2, minus another -2, and then minus j. When you do j, it's going to be, these two columns. So 1 times -2 is -2. -1 times -4 is going to be +4, so -4, and then plus k. Now when you do k, you're going to use those four. And 1 times 2 is 2, minus 1 times -4, which is going to be a -4. Okay, so what we're going to get here is, that's boring, 0i. This is going to be -6 times -1, which is going to be plus 6j. And then this is going to be plus 6k. All right, so notice that is our normal. So our normal vector is going to be 0, 6, 6. So now I have this. Once I know those pieces, now I can fill out this equation right here. So therefore, so our plane, A is going to be equal to 0. So this is 0 times x minus x naught, which is going to be right here, which is -1. So minus a -1, so plus 1, plus, 6, because this is going to be our B. And then it's going to be y minus this point, which is going to be 2. And then it's going to be plus 6 times z minus its intersection, which is going to be 1, is going to be equal to 0. And a lot of times we simplify this. Now, since that's 0, that's going to go away. So I'm going to have 6y minus 12 plus 6z minus 6 is going to be equal to 0. So then I'm going to have, that's minus 18. So 6y plus 6z is going to equal 18. Now, most of your examples, you're still going to have an x. It doesn't usually zero out. But in this example, it did. So if you like the content, please subscribe.